Hi, this is Maggie. This is our second Unified Modeling Language, or UML, sequence diagram video documenting our ProverbGame system. If you haven't seen the first video on sequence diagrams, I'll link it here and in the description. And if you haven't seen the video in which we create the ProverbGame system, I'll also include a link here and in the description. You'll want to understand the basics of sequence diagrams and the classes involved in this interaction before we draw the diagram. Briefly, sequence diagrams are a representation of the dynamic aspects of an object-oriented system and show the objects responsible for implementing a use case and the messages passed between them in order. In this video, we're going to document a small part of the ProverbGame class. This class has a main method, and we do not create an instance of this class. There are two versions of this class. One creates a Proverb Manager iterator object, and the other creates a Proverb Manager object. We'll use the version that creates the Proverb Manager object, because in that version we will not be dealing with superclass code from the Java API that we didn't write. I will begin by creating a new sequence diagram on app.diagrams.net, and as I did in the last video, I'll put the class containing the main method on the left, as this class is driving the program, and I'll label it as : and class name, so : ProverbGame. And the interaction begins with the ProverbGame class receiving the main message, so we'll show that as external to the system, and I'll annotate it with static. Now in the code, we create a Proverb Manager object called Proverb Manager on line 12. Let's label the second lifeline in the diagram Proverb Manager : Proverb Manager, and let's send it the Proverb Manager message, the constructor, with the argument proverbs.text. And now we need to look at that constructor and see if it sends any messages. It sends one message to itself. It sends the private message, read Proverbs. And this method creates an ArrayList object, a file object, sends the file the exists message, then conditionally creates a scanner object, and iterates over the file, reading from it with the scanner and constructing proverb objects and adding them to the ArrayList by sending it the add message. There is a lot here: conditions, objects, and a loop. This is the piece of the system we're going to focus on in this video, as this will show us a lot of how sequence diagrams work to document interesting interactions. Let's take it one piece at a time. First, the constructor sends a message read Proverbs to the Proverb Manager object. This is a private message, by the way, that can't be overridden. We're going to open up the UML symbols in the menu at left, and there's a self-call symbol that we'll drag out. This shows an arrow returning back to the lifeline where it was called, and a new activation box on top of the existing activation box. This will need to be longer because read Proverbs does a lot of work. We'll label the message read Proverbs. In read Proverbs, we first create an array list of proverb objects called Proverbs. So I'll drag out a lifeline and label it Proverbs : ArrayList Proverb, and we'll send it the constructor message and give it a little activation box. We will not be digging into code that is not part of our system, so we will not concern ourselves with any messages sent by ArrayList or any other classes outside of our system in its constructor. We then create a file object called file and send it the constructor with the path that was passed in, proverbs.text. So we'll create a lifeline, send a message, and draw a small activation box. Now we have an if statement, if file.exists, and if that is true, we create a scanner and jump into a while loop. So this is where the diagram gets a little more interesting than what we did before. If we have conditional execution, we can represent this in a sequence diagram by drawing a box around the messages, called a frame, that are sent conditionally. This set of messages grouped in the frame is called a combined fragment. For a simple if, we label the frame with opt. For an if-else, we label it alt. Let's begin by sending the exists message to the file object from the Proverb Manager's read Proverbs activation box, and it will send back a return value. That value doesn't have a name, so I'm not going to label the return arrow. Now we'll drag out a frame and label it opt. I'm going to drag the frame out such that it isn't connected to any one lifeline, as that's going to cause drawing problems if it is. I'm going to put it under the exists return, and I'm going to make it put its left side to the left of the Proverb Manager's lifeline. We'll be creating more objects, so I'm going to make it wider than our current diagram. We're going to put a guard under the label for the frame that is the condition enclosed in square brackets. So open square bracket file.exists close square bracket. I don't think there's a specific UML symbol for this, but I can go to the plus in the menu above and choose text and create a little text box. Again, you might be using a different tool or drawing your sequence diagrams by hand. So within the conditional code, we create a scanner on line 33. Because the scanner is created conditionally and doesn't exist otherwise, I'm going to put the lifeline within the frame. I think it's sometimes harder to read a sequence diagram if the lifelines aren't all at the top, but this object is only going to exist while this method is executing, or the reference to it will only exist while this method is executing within this conditional block if it executes. So I think this is a reasonable choice. I'll drag out the scanner's lifeline and label it input file : scanner and send it the constructor message and pass the file and give it a little activation box. Now we have a loop, and you may have guessed a loop is also enclosed in a frame with a guard. The condition that controls the loop is the message input file.hasNext. So we'll be sending that message to the scanner object before the loop as an initializer, and again at the end of the loop as an updater. The code isn't written this way in that we're not saving the result of the call in a variable and then testing the variable, but it communicates how the condition is updated each time through the loop. So we'll send that message and then drag out another frame and label it loop, and we'll put a guard on that, input file.hasNext. I have also seen these written, by the way, as something like input file.hasNext equals true. But I don't like to see that programming habit, as I think it's a habit that can result in errors, which I've seen many times. So I'm just going to evaluate input file.hasNext as the guard. Now, inside the loop is interesting, because we're reading from the file 3 times. Not super interesting. We'll just send the next line message to the scanner object and return proverb, prompt, and origin in order. But interesting because we're instantiating a new proverb object and sending it to the array list proverbs as a parameter to the add message. So in this code, we're creating some number of proverb objects, but we don't know how many, because that will depend on the length of the file. And we don't reference them individually. If we had a reference, if we had written the code to create a proverb object on one line and then pass that reference to proverbs.add, we would have only one reference. So there would most likely be multiple objects, but only one reference being used in this loop. So we're going to create a lifeline for that one reference from the perspective of this interaction, the sort of anonymous reference that's being used to create many different objects and pass them along to the array list. We'll put a lifeline in representing a proverb object that is unnamed or anonymous, and we'll label it as simply :proverb rather than giving it a name. We'll send it the constructor message after the 3 reads from the file and pass those values in. And then we'll send the add message to the proverbs array list, and we'll pass in :proverb as the parameter, the proverb object we just created. And then at the bottom, we'll check if the scanner has anything left in the file by sending the has next message to the scanner. And that's the end of the loop and the opt frame and the end of the sequence diagram, except to return the proverb's reference to the calling method, which is the constructor. I don't actually see a symbol here for a self-return, so I'm going to copy the self-call arrow and then over in the style area on the right, change that to a dashed line with an open arrow and label it with proverbs. So that is a somewhat complex sequence diagram based on the ProverbGame code. I would recommend continuing with the code to see if you can continue the diagram. Once you can do that, you're ready to move on.